So hello, my name is Prathamesh Noye. Today I'll be walking through my machine learning project titled Flipkart Customer Support Query Classifier. This project uses machine learning and natural language processing to classify Flipkart customers' queries into the written, related, or other types. Throughout the video, I'll show you every step from data loading, cleaning, modeling, training, evaluation, and prediction. And I'll explain you the logic behind each step as we go further. So first, the problem statement is Flipkart receives a larger number of customer support queries daily related to refund, delays, and product issues. Manually handling these queries is slow and inefficient. This project aims to build a machine learning model that can automatically classify the customer queries into relevant categories, helps improve response time and customer satisfaction. So first, we begin with the importing the essential Python libraries we'll be using we'll be using in this notebook. These include NumPy, Panda, Matplot, Seaborn, sklearn for machine learning models, vectorization, preprocessing, and evaluation. These are the functional tools used in almost every ML pipeline. Second, we'll be loading the data set. Third, to view the first few data set, df.head is used. This gives us the first five uh, first five data set. Next, data set rows and column count, data set information, duplicating values, and missing values are used over here. And we'll be understanding the variables, the available column in the data set. To see the available column in data set, we use this print df.column.toList. Here we see all the column name printed over here. Then checking the unique value for each variable. Data wrangling. Here we simplify the task by creating the binary target column called binary label. If the category mentions return, refund, or cancellation, we label it as one, everything else or else, and everything else becomes zero. This turns our multi-class problems into a binary classification problem focused on return-related queries, which are high priority in e-commerce support. Data visualization and storytelling and experimenting with the charts. The first chart that I used is distribution of support query categories. Chart 2 is query length distribution. I use this chart to understand how detailed customer messages are. This affects model complexity and chatbot design. The third chart that I use is word cloud one. I choose this word cloud because it gives a quick visual overview of the most common keywords used in customer queries. It is a great way to identify the top recurring complaints with deep analysis. The chart 4. This is a bar chart which shows the average customer satisfaction score for each category, for each issue category. The visualization helps to identify which type of queries are handled well and which ones may need improvement in service quality. The next chart is horizontal bar chart to understand which cities have the highest number of customer support queries. It helps Flipkart identify regional hotspot of complaint, which is important from the operational planning, logistics, and improving customer experience in key market. The next chart is multi-bar step plot to analyze the relation between query length and support category and customer satisfaction. This chart shows how message detail length may impact satisfaction and whether it varies by issue type. So there are three hypotheses that I use. The first hypothesis is return-related queries have significant lower CSAT score than the other queries. We will use the T-set or ANOVA to compare the average CSAT score between return-related or other queries. The second hypothesis is the average length of return-related queries is longer than the other queries. We'll perform two sample t-tests on query length between both classes. The third hypothesis is customer city and query length, return or other, are not independent. For this, we'll use the chi-square test for independence between two category variable, customer city and binary level. So for hypothesis 1, we use ANOVA test, which gives a F statistics 67.07 and p-value is 0. So if p-value is less than 0.05, there is significant difference between the least one category, means CSAT, or if it is greater than 0.05, no significant difference was found. In second, we use two hypotheses, null hypothesis and alternative hypothesis. Null hypothesis is no correlation between query length and CSAT score. For alternate hypothesis, query length is correlated with CSAT score. In this, we got the correlation efficient as 0.22 and p-value as 0. This is a Pearson correlation test results. I use Pearson to evaluate the linear relation between query length and CSAT score. This test returns between the correlation strength and pi value to assess significance. For third hypothesis, I used chi-square test for query distribution across cities. The chi-square statistics that I got is 74.21, 745.21, and the pi value is 2. This gives the conclusion that the query distribution is not uniform across cities. Now, going to the next topic, featuring engineering and data pre-processing. So, handling missing values. So, for handling missing values, I use the function df.null.sum, which gives all the clean data shape in the data which we have. Handling outliners. In categorical encoding, textual data processing, then data scaling. For data scaling, I use mean max scalar method from sklearn.preprocessing to scale the numerical features as item price and query length. I choose it because it keeps the data in uniform scale. It improves model process by combining numerical features with TF-IDF output, and it helps avoid bias towards features with larger number of ranges. Data splitting. I use 80/20 mm, train dat- train test split, where 80% of data is used for training and 20% is reserved for testing. Enough data for the model to learn and pattern, a sufficient portion for unbiased evaluation. I use satisfied splitting to maintain the class balance between training and test set, which is important for binary classification and avoid skewed result. Now going to the ML model implementation. Now we train a machine learning model. I use logistical regression as it is simple, fast, and works very well. The model is trained on TF-IDF vectors and the binary labels. The accuracy that I got is 0.60, means which is almost at 60%, and use joblib for deployment to save model vectorization and encoding. To improve the performance, I applied grid search CV2 time to tune hyperparameters like C and solver. This step uses cross-validation to find the best model configuration. The tuned model performed slightly better and is now robust on uncertain data. To say that which ML model I choose logistic regression on my final prediction model. This is because I perform consistently well on TF, IDF, vectorization techs. I gave a good balance between precision, recall, and F1 score, especially for the return related class. It is the first interpretable and works efficiently for binary classification problem involving high dimensional spread data like tests. After applying hyperparameter tuning and class balancing, logistic regression achieved the best business related result with around 60% accuracy and reliable prediction. Therefore, I selected as the final model for deployment due to simplicity, performance, ease of integration. Save the to next topic. Save the model. Once I had the final model, I saved it using joblib. I also saved the TF-IDF vectors and label encoders so they can be reused later without retraining. This PKL file will be used to deployment via Streamlit or any backend API. So here again load the files using saved model to predict unseen data. Here unseen text is I would like to return my damaged shoes. For that we got a result of the one which is called return, refund or cancellation related. If you put here like when will my model when will my order arrive, we get the predicted class and other queries. In this project, I successfully built machine learning model, classify Flipkart customer support queries into return related other categories. I use TF IDF for text feature and extraction as feature extraction and logical regression for classification. The model achieved around 60% of accuracy and was further improved through hyperparameter tuning. Finally, the model was tested on unseen data, and prepared for deployment. This solution can help automated support query handling, reduce manual effort, and improve response times. Now we'll just deploy a model. So we got a model. Flipkart customer support query classifier. This app predicts whenever a customer query is refund related, return related, or other. So putting the if customer puts the message when will my order arrive, the query is other related. It is not related to return or refund. Or if we put a query as got a damaged order, so it will be like return and query related. So if you put a customer query as I got a damaged shoes, the query will be like return and refund is this. This this project will be easier for Flipkart to uh, categorize and filter the queries if it is feedback or return refund related. That's all for that is my project.